a year, how many people do they need now, according to the elasticity definition, to have no change in total revenue? The point elasticity definition. How many more people do they need? And besides that, exactly how many people do they need if you're looking at point elasticity? I want an answer. The answer is very simple. What is it? Where was that came from? 40,000. How'd you get that?
Did it drop by 40%?
Yeah. Price dropped by 40%. To have no change in total revenue, you have unit elasticity. Therefore, quantity demanded would have to go up by 40%. Therefore, starting with 1 million, you'd have to have an increase in visitors of 400,000. Hardly a small increase. All right, now then, first point. The second point is this. Does, in fact, that give the same amount of revenue? What's the original revenue? 25 million. Because you're supposed to be thinking about these people. You're going to be in business in some way or another. You can't avoid it. How many here are planning to be novelists, poets? I mean, that'd be nice on the side. You know, doctors, maybe lawyers. But otherwise, even, virtually everybody but a poet, pretty well has to know about business, and we need to know about this. And it's pretty straightforward. So let's just figure it out. You want no change in total revenue, because if total revenue decreases, the mall has to cut back on buying stuff, and the hours that it's open and all the rest. So, originally you got a total revenue of 25 million. Our point elasticity prediction should be that we increase by 400,000, which would mean we'd have 1.4 million visitors that we're charging $15 to. How much is that total revenue, by the way? The rest of you start using your calculators. I don't want to be talking to people who aren't working. You understand. 21 million, bang. If you can't do it in your head, you're doing it with the calculator. So, it turns out, if you get 400,000 more visitors, you will not, in fact, have the same amount of total revenue. Now I want to know, why not? Why wouldn't you have the same amount of total revenue? Because what? Sorry?
The demand for the wrong liquor is not, at that point, it's not allowed.
At that point, right?
It doesn't maximize the
Why we claim, the whole idea is that if you increase quantity demanded by the same percentage, you decrease price, you will not change total revenue, but in this case, you know it's wrong. Tell me why. Tell me why. Well, I already told you why. Because elasticity is for 1 point. If it's a very small change in price, if the price went from 25 to 24.50, and we increased the output by 40% relative to that, or whatever that increase is, it would work perfectly. But elasticity changes. We went from 25 to 15. We went way over the demand function, right? What do we need to use? Arc elasticity. Okay, now you don't know anything about arc elasticity. You're the CEO of the ROM. All you need to do is give me the most simple answer. Forget about this elasticity drivel. How many visitors do we need at $15 to have the same total revenue as at $25 and 1 million visitors? In your heads, I want a total revenue of 25 million. I'm selling tickets for $15. How many visitors do we need? 1.666. Very simple, 25 divided by 15, 1.66. So it turns out, again, Janet Cardy, one's frightened, I'm seriously frightened about the ROM, needs 2/3 of a million, which is almost doubling their attendance to make just the same amount as before. Everybody? Not a little bit over a million. Now, by the way, you can figure that out with a little bit of work. I wouldn't ask you to figure that out in an exam. You could do it. Because what you would do is this. You would say, it turns out, you would figure out point elasticity. What is the fall in price according to arc elasticity is 25 to 15. That's 10 divided by the average is 20. Price falls by 50%. So the change in quantity relative to the average Q has to go up by 50%, right? But we don't know what the average Q is because we don't know what the Q is. So you'd have to say 0.5 equals the change in Q, Q1 minus Q1 million, the new Q, divided by the average Q1 plus 1 million divided by 2, and you need to solve that, which is reasonably easy, but I wouldn't ask you on the exam, right? But you see the point. This is the kind of thing we do. We look at the elasticity to predict. So I need you guys to think like that, percentage change, percentage change. Okay, now a couple of other things before we take a break. You're looking a little bit freaked right now. I'm telling you, you're freaked. Do the stuff and start walking around. Walk around UT. One time I did my orals, I just walked around the town for 8 hours. Just walk, and brought it all back. Sitting in front and staring at pieces of what I wrote won't do it. Dredging it out of your own mind will do it. Think about this, and it'll be there forever. Then you just walk in. Okay? So make sure you think about it. I've given you all these examples. I'm going to give you some more stuff too. Percentage change, what it means, right? Good. Very practical. Okay, good. Now, let's get rid of this. And this. And this. And I'll get over here. I don't need this. I need this. Okay, good. So, let's see what's not on the exam. Where we're at. All right? I'm going to show you everything before the break that's based on the exam. We'll do it. So the only thing that's not on the exam, all this stuff, read it, please read it. I wrote it. If you read it, it should bring things together for you. Assuming there's no typos. This part here, you'll notice. The bottom of page 4, where that bracket is right there, to the end of page 5, right there, you do not need to look at it. It proves to you about the relationship between total revenue and percentage change. But basically it talks a lot about marginal revenue. We don't need it right now. So forget about it. Right? Forget about it. That's not on. Don't email me. It's not on. Bottom of page 4, total page 5. Then all the rest, blah, 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 examples, elasticity, slope, da-da-da-da-da-da. Here, this isn't all that interesting. You can just think about it, why that might be the case. There are, oh yeah, we need this now. We need to define what a vertical demand curve is called perfectly inelastic. Everybody? Perfectly inelastic. Elasticity ranges from 0, that is perfectly inelastic. Think, elasticity is the percentage change in Q divided by the percentage change in P. If Q doesn't change, that is 0. It's perfectly inelastic. And that happens in something like insulin, or if someone in athletics is training and wants to buy just so much of each type of food, doesn't matter what the price is, they buy the same amount, right? Perfectly inelastic, vertical. Perfectly elastic is horizontal. All that now, when you see it as horizontal, you can't quite understand it. But think of it as just a little bit negatively sloped, but very flat. And all it means is if the price changes by a small amount, everybody buys it. If it falls by a small amount, huge numbers of people buy it. If it goes up by a small amount, nobody buys it. This occurs if you have a perfect substitute, right? Right, Reed? That's called perfectly elastic. So, for example, Pepsi and Coca-Cola are the same price. The beer, for the most part, is the same price. If your beer is a little bit more expensive than other beer, nobody thinks your beer is better. Nobody buys your beer, right? So everybody has the same price. Okay, so that you need to know. This you do not need to know for this exam, but I'll explain it nonetheless. I don't know if I've got it. So the one you're going to be interested in is the price elasticity of demand. the elasticity of moving along a demand function. But there's also the responsiveness of quantity demanded to income, right? Change in income. Let's just think about this, everybody. The income elasticity of demand is elastic, inelastic, and otherwise. But the only part of that that's interesting is it tells us the relative shift of how much it might be. It might give us a sense of how much the demand curve shifts. For you guys, what's important is the sign. So I'm just going to ask you this very simple question. And I might ask this at an exam at some point, or I might give you the information this way. I might say to you, the income elasticity of a good is negative. What type of good is that? It's an inferior good. Percentage change in quantity demanded goes up when the income goes down. It's an inferior good. If income elasticity is positive, it is a normal good. And that's really all we're interested in that. Everybody? Okay? Other than, like, and this might be 1 mark in the whole course, not much more than that. Cross-price elasticity of demand is simply the responsiveness of quantity demanded in a percentage way to a change in the price of some other good. So the percentage change in the quantity of X relative to the percentage change in the price of Y. Now, if that's a negative number, what is the relationship between those two goods? If the quantity demanded of X goes up, when the price of Y goes up, what is the relationship between Y and X?
Complementary.
Are they complementary?
They're substitutes.
They're substitutes. So when the price of Y goes up, say the price of coffee, the demand for tea goes up, right? Complements is negative. Everybody, this isn't difficult, and I'm not asking on this exam, but I expect you to know it somewhere along the way. Okay, then we have the elasticity of demand. Elasticity of demand is really simple, so I don't spend a lot of time on it. The elasticity, of supply. The elasticity of demand is interesting because when price goes down, quantity goes up. We have this whole issue of whether total revenue is going up or down. But supply, when you move along a supply curve, if price goes up, quantity goes up, total revenue goes up. Big deal, always and forever. If price goes down, total revenue goes down because quantity goes down. Not interesting. But otherwise, you can have elastic supply. And in fact, it's easy. But I'm not much interested in elasticity of supply, particularly in this example. We're interested in the elasticity of demand. Everybody? And on the final, it's mainly the elasticity of demand. Okay. Then, so although this is in your notes, this is not on this exam. This, though, is very interesting, and let me point it out to you. I keep trying to tell you guys that, we talked about Adam Smith having this concept of demand and supply. He literally defined demand as how much people would buy at what he called the natural price, that's cost, right? So for him, demand is how much people will buy at the natural cost. And he assumed cost was constant. And then on the cost side, supply is how much people would supply at the cost, right? Everybody? So you've got 2 points. And it may happen that demand, as he defined it, is greater than supply. But as I showed you before, he knows that price has to go up if demand is greater than supply, and price has to go down if supply is greater than demand. But he has no clue where it's going to go, because he only has those 2 points. 2 points right there. So subsequently, eventually get Marshall showing how demand is this relationship between quantity demand and price for all prices. And you got a demand function. So if supply shifts, you can figure out what the new price is. So that's a much greater advance. But Marshall also pointed out an explanation for what it was totally puzzling to economists. The classical economists argued that demand did not determine price in any way, shape, or form. Only supply determined price. That for 100 years, they said, supply determines price, demand has no role in price. And then following them in the early 1870s, before Marshall kind of cleaned it all up in like 1890, the Marshall revolutionaries said, actually cost has no influence on price, only demand influences price. So you've got 2 diametrically opposed things. One says cost determines price and not demand, and the other says demand determines price and not cost. What is the problem here? And Marshall showed basically this. I'll jump out of here. hang on, we're just ending here for the moment. He showed, look, the classical economists thought that cost was constant. If you're a shoemaker, for example, remember they're writing in the early 1800s and 1800s. If you're a shoemaker and you make shoes, the first shoe costs the same as the 100th shoe. You know, what's the deal, right? Every shoe costs the same. So basically, cost is constant, supply looks like that, right? Doesn't matter what you produce, the cost is the same. Therefore, who cares about demand? In the sense that we do it. Supposing demand is this, what's the price? Supposing the demand even looks like this, who gives it? You know, here's the price, right? Here's the price. It's always the same. Demand has nothing to do with it, right? So notice, just because of that conceptualization, now the martial revolutionaries, they actually don't even use supply. They don't they don't think about cost or anything like that. They say cost has nothing to do with that. They say it's only demand. We'll talk about that actually in the class today. But Marshall pointed out that they do have a concept of supply, and that is supply is given. It's just given. They talk about two people meeting somewhere and each of them has apples and oranges and they trade. But the assumption there, whether they even know it, is there's a fixed supply, right? So notice, if supply is fixed, if it's already fixed, if there's no production, and there's only a certain amount of supply, this is what supply looks like. And if that's the case, the only thing that determines price is demand, right? So basically Marshall showed, if you consider supply to be perfectly elastic, then only supply determines price. If you consider supply to be fixed, perfectly inelastic, then only demand determines price. And then Marshall said to these guys, basically, all right, boys, you're pretty sharp. Now you tell me what determines price, their supply. You tell me what determines price. And of course, there is no answer. Because if you knew the quantity, you would know the price of demand. But you don't know the quantity. So then Marshall says you have to have supply and demand always and forever. The two of them are always necessary, except in those extreme instances. And that's where kind of modern economics takes off. All right, good. 10-minute break, and then we're on.